rational and irrational numbers. Notes. So today we will learn how to classify numbers into two groups, whether it's rational or irrational. So some key terms and definitions we need to first learn before we can identify the numbers are that rational numbers can be represented as a fraction or ratio of two integers where the denominator cannot be 0. So a rational number can also be or is terminating and repeating. So irrational numbers cannot be represented as a fraction or ratio. So it's basically, if it's not a rational number, it's an irrational number. Of two integers where the denominator cannot be 0, it is non-terminating and non-repeating decimal. And recall that integers are all whole numbers and their negative opposites. So -3, -2, -1, 0, 1, 2, 3, and so forth. Okay, so we have those definitions. So now we're going to try to classify the following numbers as either rational or irrational and explain how we know. So -45, is it rational or irrational? It is rational. And it's rational because it can be represented as a fraction. -45 over 1. The next number, 2 point repeating 5, is rational. It has a repeating decimal. So next number, -5.242 ... It means the number continues. There is no repeating pattern. And it doesn't end, therefore it's an irrational number. So it is a decimal that never ends and doesn't repeat. Okay, the square root of 36 is 6, which is a whole number, and 6 can be represented as a ratio, 6 over 1. Therefore, it's a rational number. Okay, let's look at the next number, 2 over 12. So 2 over 12, yes, you can further simplify the fraction, but just because it is a fraction, it is a rational number. So the next number is the square root of 8. And the square root of 8, we can't find a number that, when multiplied by itself, will give you 8. But the square root of 8 will give you decimal number, which is, if you put it in your calculators or if you approximate it, it will be 2.828 ... There's no repeating pattern. Therefore, it is an irrational number. Also, the square root of all non-perfect squares will always give you an irrational number. So it is an irrational number because the decimal never ends and doesn't have a repeating pattern. Next number, 4.582 ... Again, it is irrational. And for the same reason as above. So 5 pi. Pi is an irrational number, so 5 times a number that never ends or repeat will also give you an irrational number. A decimal that never ends or repeats. So 5 pi, if you put in your calculator, it will give you 15.707 ... And 2.25 terminates, therefore it is a rational number. Negative square root of 13. 13 is not a perfect square number, so it will also give you an irrational decimal number. If you put this in your calculators, it will give you -3.605 ... So it is a decimal that never ends and no repeating patterns. And that is it for the actual lesson, how to identify one or the other. And here are just some questions that you can answer to just get better and stronger at it. So question number 2, which doesn't belong? And explain. So all these numbers are all representation of rational numbers except for one, which is 0.33 ... which means that, so 0.33 doesn't belong because it's the only irrational number, a decimal that does not terminate or repeat. Even though it looks like it does repeat because it's 3, So here's another question. The area of Ron's square desk is 16 square feet. Is the side length of the desk rational or irrational? So to figure out the side length, you'd have to find the square root of 16, which would equal to 4. So the square root of 16 would equal to 4. And 4 is a rational number because it can be represented as a fraction. So the side length is 4 feet, which is a rational number. Question 4, true or false? 2 point repeating 3 is irrational because the digit 3 repeats. That is false because that actually makes it a rational number, a repeating decimal. The sum of the square root of 25 plus the square root of 36 is a rational number. That is true because the square root of 25 is 5 plus the square root of 36 is 6, which is 11, and 11 can be represented as a fraction. The following 3 numbers are all rational: 5, 5.55, and the square root of negative 25. And the answer is yes, true, because even all of these numbers either terminate, and the square root of negative 25 is negative 5, which can be represented as a fraction. Finally, the last one here, the sum of the square root of 2 plus the square root of 2 is a rational number. The answer is false. Both of these numbers, the square root of 2 plus the square root of 2, will give you 1.414 with a continuation. And if we add a number that continues plus another number that continues, we'll always give you a sum of a number that never ends. Question 5, solve the equation x to the power of 2 equals 10. Is the solution rational or irrational? Explain. So x to the power of 2 equals 10. We need to isolate the x. To isolate the x, I'm going to find the square root of x to the power of 2. What you do to one side, you do to the other. Therefore, x is equal to the square root of 10, which would be 3.162 ... So the solution is irrational because it is a number that doesn't end or repeat.